Zhengyuan, I think you can just start.
Let's wait 3 more minutes. There's still people being admitted.
All right then.
All right. I think we're still admitting some people in, but I think we can start with some of the introductions first. So good afternoon, everyone. Welcome to Building Blocks 2021. So today, the workshop that's going to be carried out here will be Introduction to C++, and it will be carried out by Zhengyuan and Yongqian. So without further ado, I'm going to invite them to just start first. All right. Thank you.
All right, hey guys, thanks for the intro. Yeah, I'm Zheng Yuan. This is my partner in crime, Yongqian. We're here to do a basic C++ workshop for you guys today. So just a little bit about us. We're JC2 students from Dunman High, and we take H2 computing for A-levels. So we're mainly specialized in Python, HTML, and the like, but we decided for like this year's BBCS workshop, we do an introductory course into C++, which is a programming language that we were already previously kind of interested in. So sit back, relax, let's convince you why you should take up C++ or just programming in general. So Yongqian and I made this workshop with the understanding that to newcomers of programming, workshops like these could be really intimidating and daunting due to like a lack of tact on the teacher's part to consider the complexity of these concepts to be taught. As a result, we have tailored this workshop specifically to be extremely comprehensible to a complete idiot to computer science. A disclaimer is that although some of you may have already been like a bit acquainted or maybe ventured into programming a bit and may recognize an abundance of these concepts, we will humbly ask that you will follow along at our pace for the benefit of the people who may not be as familiar with them. So that being said, let's just jump right in. All right, so let's quickly run through the contents of this workshop with who's doing what. I'll be covering the first half of this workshop with a basic guide into programming languages, some essential knowledge on C++, as well as a vital toolkit to some must-know C++ concepts. So my section will be very, very theoretical, so you don't have to worry about coding anything yet. But this will change as Yongqian tackles the second leg of the course, which will elaborate on variables, conditionals, and loops, which are quintessential concepts in programming. In this section, you'll get your chance to flex your practical chops a bit more and follow along to some cool-ass live coding. All right, so moving on, Programming Languages 101. In this section, we will take a dive into the concept of a programming language and why learning is so important. So, what even are programming languages? Before we even move into C++, this is the most crucial of questions. And so, totally not ripping off the Wikipedia definition of a programming language, we get this. Programming languages consist of instructions for computers. Yes, this is very true. At their core, programming languages are essentially sets of instructions for computers to do something that you would like them to do, whether or not it be saying hello to a visitor, logging into a web page for the first time, or something super duper duper complex, like calculating the rate at which the universe expands or something. However, in getting our computers to do our bidding, there's one glaring problem, and that is that computers simply don't understand what we have to say to them, which is why programming languages are so vital to beginners. So now I've indexed some examples of programming and human languages. You may have seen some of these before. On the left side are some very popular programming languages like Python or Java. On the right, there's everyday human languages that you and I speak. Stuff like English, Japanese, French, you know the deal. And this is what machine code looks like. I'm sorry, I know this looks very disappointing. This is binary. This is the language in which computers use to function. As you have noticed, it's literally only consists of zeros and ones, hence the namesake binary. However, it's exactly these zeros and ones that when you string them together, there's emergent meaningful functionality that is able to flourish. This is why it's so important to distinguish between these types of languages and how programming languages may swoop in to serve as a vital middleman between humans and computers. So to better illustrate my point, here's the scene of an angry, possibly drunk programmer yelling at his computer. Little does he know his efforts are foolish and in vain. The computer ignores him as he goes on his pointless tirade. Now the man comes down and he chooses to communicate to his computer in a programming language, which is then translated into machine code, which the computer is able to understand. So the computer gleefully responds. So in summary, humans speak our own languages, but computers speak in binary, which is their own language. Programming languages like C++ serve as kind of like a vital middleman between us and our computers, which acts in turn kind of like a lingua franca, like how English binds Singaporeans of different cultural backgrounds together. We all speak English and we are all able to communicate with each other and understand each other. Moving on, let's talk about how C++ came about and a brief overview of its functionalities that enable it to become so popular and widely used today. So why is C++ called C++? What's even the whole point of the plus gimmick, right? I know what you're thinking. This is a language called C, right? Well, no, there isn't. Who am I kidding? Yes, there is a C language, and it's still even used today, actually. although maybe to a much lesser extent than its slightly dysfunctional cousin, which is C++. I was kidding about that last part. They both have their place in programming. And yeah, at any rate, to understand the history of C++ is also to understand the history of C. So between 1972 and 1973, this guy called Dennis Ritchie authored the C programming language while he was working at Bell Labs, which is a US research facility. So C was really good for efficiency because it has some features such as low-level memory access. However, there's a catch, and that is that C is a procedural language, and it does not provide object-oriented programming or OOP features. If you don't know what these fancy schmancy terms mean, do not fret. These are a bit more higher level, and you just have to understand that a lack of OOP functionality is usually considered a limitation for a programming language. So anyway, this written response to this, right? This Danish dude, Bjørn Strustrup, who also worked at Bell Labs, began working on C with classes in 1979, which essentially added those much needed OOP features that were missing from before. So in 1983, this new rendition of C was named C++, and it saw its first commercial release in 1985. And these very handsome-looking elderly gentlemen are Strustrup and Ritchie. Strustrup is still very active in the programming scene, and the same goes for Ritchie, who sadly passed away a few years ago. So since then, C++ has gone through many standardizations. The last one was in December 2020. It continues to be governed by the International Organization for Standardization. The diagram is actually quite bad at illustrating how many iterations of C++ has gone through since it's obviously been standardized regularly from 1983 to 1998 and beyond that. As well as obviously there's the 2020 rendition, and this is done so, the standardization, I mean, is done so at a frequency of about 3 years. So let's talk about why C++ is such a versatile programming language that you should learn, as well as some recognizable and popular applications of it. So the first benefit is performance. By putting the programmer very close to the hardware, C++ lets us write very efficient programs, which, along with low-level memory access, as well as low abstraction, think of it as like kind of like the distance between code and what the machine will do, is smaller than most other languages. So the programmer, you, can manipulate the system a lot more better. The next thing is portability. C++ is a very portable language, meaning that you can cross-compile it onto a myriad of platforms. And it runs on everything from watches to TV. If you're writing an application or a library for more than one platform, C++ really takes the cake. So for example, right, if you wanted to code a C++ program on your MacBook, you could theoretically compile that code to, let's say, a really, really, really smart toaster. And that toaster will still be able to carry out those exact functionalities, provided it has the required parts, that being the hardware, to do so. Another benefit is versatility. C++ is a jack of all trades. The programming language is very, very versatile. It can be used in everything from video games to enterprise. Since there's a huge variety of functionalities, including direct memory management to OOP, you can definitely make C++ work for you with any program that you want to make. Another benefit of C++ is that since the language is used in so many applications, there is an abundance of libraries to choose from. With hundreds of open source repositories, there is a wealth of information and support systems that come with that information. However, as the old saying goes, nothing is perfect. C++ certainly comes with its own sets of limitations. C++ gives you the opportunity to do great things, but also get yourself into, pardon my French, deep shit if you use it incorrectly. So beyond Strustrup once said of the language, C makes it easy to shoot yourself in the foot. C++ makes it a bit harder, but when you do, it blows your entire leg off. And the metaphorical, gory and violent nature of it aside, that's not by any means to say that C++ is bad and should be avoided. It's just that it should be used extremely deliberately and with consideration. So here are some popular usages of C++ that will bound to make you go, aha, I've seen that before. So C++, as mentioned earlier, is particularly great in its cross-compilation, low-level memory access, and OOP, which makes it very, very ideal for app development. This could range anywhere from like your popular video streaming sites like YouTube to entire web browsers like Google Chrome, which no doubt many of you are using at this very moment. So here are some examples of some apps that are coded in C++ that you and I may see in our everyday lives. Of course, I should mention that for a lot of these apps, they are very complex and they likely have been coded in multiple languages. However, it should also be noted that C++ often forms the important like backbone of several of them. Like, for example, C++ is used to code YouTube's video processing functionality, which is pretty much like the whole point of YouTube. It's the most important aspect of the app in the first place. Oh, here's another number on you guys. Game engines. Your favorite video games have likely been developed from the ground up using a game engine which was coded in C++. The game engines provide the developmental environment, game physics, and visuals, which are coded in C++. And here are some of the more widely used and discussed game engines in modern game development, such as Unreal, Source, or Frostbite. And here are some examples of games that have been coded in C++. Of course, the list goes on for many, many, many miles, and you might just be extremely surprised at how your personal favorite games might have also been pieced together with C++. Before we break for the intermission, I would like to impart on you guys some C++ concepts that will no doubt be utilized and be put to the test in your coding endeavors. If you were slightly snoozing for the previous section, please try to perk up your ears a bit now, because these concepts will be very fundamental to your understanding of the language, as well as Yongqian's section later on. So before we move on, can everyone please go to your browser and access this link over here? We'll pretty much be using this for the rest of the lesson. So perhaps you can open this tab somewhere first and we'll be able to use it later. I'll just give you guys maybe like 2 minutes. Just access the website, maybe in a separate tab, and just keep it open there. All right, I assume that everyone's already done that, so I'll just move on first. So before we move on, I should also briefly explain what inputs and outputs are. So inputs in a program are exactly what they sound like. You take some data, you input it into the system, yeah, pretty much. But however, the data that you can input can be anything really, like as long as it's recognizable by the computer. It could be a string, it could be an integer. Do not fret, Yongqian will definitely cover these different types of data in detail in his section on variables. Outputs are the opposite. Basically, based on program code, otherwise the instructions that you provide for the computer to perform, the computer will output one or more values. These can be any kind of data that is processed and interpreted by the system. So here's an example to better illustrate how outputs might work. Don't worry, this looks very intimidating, but I'll walk you through it. So this over here is by default what you should see when you first open up your C++ shell. So I removed everything, replaced it with this code, which should yield a hello world program. If you don't know what a hello world program is, don't worry, just think of it as like sort of a passage that every programmer goes through whenever they have to learn a new programming language. Essentially, it's just to get the terminal. Think of it as the computer's way of speaking to you, of displaying the words hello world. And if we run this program, we will get this. the box over here that should be near the bottom of the page is what we call the terminal. It is what displays to us the output of the code that we pass through the C++, for the Hello World program. Before we go any further, let's take a moment to analyze and discuss the C++ build pipeline. This is the process that turns the code that we write into something that our machines are capable of running. Remember how I said that C++ serves as an intermediary between our computer and us? Well, that is not exactly super accurate either, because again, computers technically only communicate in machine code, so they don't natively read C++. So they are unable to run our C++ programs as we write them. They have to be first compiled into what is called an executable file, sure. So these understandably sound like a really complicated process, but I promise it'll be easier for you to see once I break it down a bit for you. Basically though, this process consists of a number of discrete steps and transforms our code into a more machine-friendly format along the way. So first up in the pipeline is this thing called preprocessing. The preprocessor, as the name implies, runs through our code before it is compiled. So essentially, this step resolves many things, such as include statements, which we will look at in just a second. Our files are still human readable at this point. So the preprocessor is pretty much like kind of like a useful editor that will run through your code a bit, do all the little jobs you've marked, and then prepare our code for the next step, which is compilation. Compilation is where the compiler takes our human readable files and converts them into binary, essentially translating our code from human to machine language. They are stored in object files that end with either .o or .obj. Consider the small Hello World application we dissected earlier. All that code lives in a single file called main.cpp. If we were to pass that through a compiler, we will get back main.o, which is an object file containing the binary version of our source code that our machine can run. Unfortunately, you can't just directly execute an object file, so it's not quite ready to run that. But the final component of our pipeline, the linker, will take care of that. The linker is the last step in producing our executable. Once the compiler has turned our source code into binary objects, the linker comes through and links them all together and puts together our final executable. So again, these three steps are what every C++ application goes through, whether or not it be a single file program such as the Hello World program that we just discussed, or a multi-thousand file application that you might see in the real world, such as your video games. These fundamental steps will always remain the same: preprocessing, compilation, then linking. Different operating systems have different tool sets that perform these actions, and covering all of them will just take away the focus from writing C++, this might actually create different experiences while you're coding, depending on the setup, since they're always changing. That's why in this course, we're using cpp.sh, which is an online compiler, because not only can we jump straight into writing the code, but we can also be sure that everyone gets the same results. So let's talk a bit about preprocessor directives. Mincing my words. The preprocessor directive is a statement that runs right before our code is compiled, which is incredibly useful for a range of different things. This can be from header files to selective code compilation. One of the most common directives, called include, we've already looked at. It means copy here, which when the preprocessor runs, it will literally copy and paste the contents of the included file in its place, which means any functions, variables, classes, and so on defined in that header are also now accessible by the class containing the include directive. That was a mouthful, but hopefully you guys will be able to digest this as the lesson goes on. Anyway, things like the IOStream header contains everything we need to interface with our applications using our keyboards, which allows us to get data into and outside of our application. This is accomplished through the standard namespace cin and cout objects. We will touch on cin and cout in a second, so don't worry too much about that. So let's talk a bit about functions. functions in C++ essentially condense code into functionality. In a sense, they are kind of like factories. We give them a set of instructions and they poop out some form of data that we want, either to be used in the program or to be outputted to us. We can then call these functions instead of duplicating code, like copy and pasting our code throughout the entire project. For example, consider a small application that asks users for their names, says hi, and then stores their name on the list. A function is split into two parts. There's a declaration and there's a definition. In the function's declaration, you're declaring that the most basic information about how the function will work, which is namely the types of values that it can return, its names, and these things called parameters, which are we'll touch on in a second. And the actual like logic of like the function's behavior is also kind of like dictated by the definition. Anyways, here are the different parts of a function. First, we have the return type, which is the type of value that you will want to return from the function, which is what you want to get, the program wants to get from the function. You can also return this thing called void, which is basically a C++ keyword if you don't want to return anything. For example, if you had a function that added two numbers together, your return type might be an integer. Say you wanted to add 1 to 2, 1 plus 2 equals to 3. 3 is an integer, is the integer data type in C++. We also have the function name, which is the name of the function and how you will want to kind of like reference it later on in your program if you wanted to. The last thing is parameters. Parameters are essentially kind of like optional sets of values that you want to pass into a function. Again, taking the example of adding two numbers, you have two integer parameters, which is your first and second number, 1 and 2. I know these sound a bit daunting, but nothing comes easy in programming, and with practice, you'll surely eventually know these like the back of your hand. So looking at our Hello World program and its main open parenthesis, close parentheses function, the reason why there's a return 0 is a bit more complicated. But in this course, for the sake of simplicity, we won't be touching on the very intricacies of functions. We just need to know that the return 0 statement is necessary to ensuring that this program runs. So let's talk a bit about I/O, or input-output statements. These come in the form of code written as cin and cout. Don't say sin and sout because that is kind of wrong by definition. But yeah, so let's talk a bit about std namespace. What is it? So std namespace, as in like adding the prefix of std followed by a double colon, essentially dials up the C++ standard library, which contains the output and input functionalities that need to be used. For example, std : cin is used for the I statement, and the std : cout is used for O, or output statements. So cin, it reads the data from our keyboard, and we need to use it with this thing called the extraction operator, which is kind of like a double, I'm not sure which direction my camera is facing, but you get the idea. It's kind of like a double right arrow. And the input data works for strings, and it also works for numerical values like integers or decimals. And this input data may be assigned with a variable, which Yongqian will again talk about later on. So in this example, you see the std name and the std age. These are I statements. They are asking the user of the program to input data, which it will then store somewhere inside the program's memory. And yeah, so in the terminal, these inputs are usually displayed in the terminal in the form of whatever you were trying to get the user to input. For example, we asked them to enter their name and their age, which in this case, we inputted John and 10. And then based on this, this code, again, given that we asked the program to output their name and age, the program at the last two lines also outputs John and 10, which is the age and name that they inputted previously. So cout is kind of the functionally the opposite of this, but there's a catch. So instead of using the insertion operator, which was two right arrows, instead cout uses, what was this? The extraction operator, my bad. Yeah, so instead of using the extraction operator, you're using the insertion operator. So this will be marked by two left arrows. Or is it this way? Never mind, doesn't matter. It works for both strings and numerical values, same as cin basically. It can also output variables, which are variables. Yeah, sure. We'll cover that later on. We will get to that. So cout, for instance, back to our Hello World program, we wrote this line in line 5, std cout hello world. So basically, this is telling the program to output the words hello world. And this is what we get. So this is pretty much the most basic O statement that you can program. So we got into the intermission. Feel free to use this time to clarify any questions that you may currently have while Yongqian sets up for his section of the workshop. I understand that this section so far is very, very content heavy with lots of theoretical knowledge. So please type in the chat if you have any doubts regards to anything discussed so far. Rest assured that you will have plenty of opportunities to practice and put your knowledge to the test in the next section after Yongqian goes to a bit more detail with regards to the technicalities and nuances of coding a C++ application proper. Will the slides be sent? Unfortunately, at this moment, there's no plans to send the slides, but if we eventually edit them a bit and then like make them a bit more readable, then sure, we will make a rendition of the slides that can be sent.
Hello, I have a question.
Okay, sure, shoot.
Yeah, hi, my name is Naja. I'm from RP. I just want to find out, like, can C++ be used for machine learning and managing big data?
Yeah, for sure. C++, actually, I intended to kind of like, at first I was debating on whether or not I should include that, but yes, C++ can definitely be used for machine learning and yeah, like with big data.
Right, so like there should be things like modules or libraries that we can use for machine learning?
For sure. There's tons of resources like that online. I'm sure if you Google around for a bit, you can find them.
What are some examples, like just one or two?
I can't think of any off the top of my head since I've never ever done anything with machine learning or anything as complex as that with C++. But there's definitely, if you just Google right now C++ machine learning libraries, there will be pages of it that will turn up.
Right, okay, thank you.
Right, I guess we can wait another minute or two, then I'll get started.
Yeah, we'll take questions until about maybe 2:07. Yeah.
Does this work? Oh dear.
We gotta wait for a second for it to
Alright.
show. Yep, it's working.
Okay. Hold on. Is it Sharon?
By the way, guys, feel free to shoot more questions, not just for my section, but for like the whole thing later on after the workshop.
Hold on, give me a moment. All right. Is it good over there?
Yeah, we're good.
All right. So yeah, let's get started then. Hi guys. Yeah, I'm Yongtian. I'm Zheng Yuan's quote-unquote partner in crime. So yeah, let's just get started.
Wait, I think he's having connectivity issues. Give him a second.
No one can hear him.
Oh yeah, he just texted me that he has some technical issues with his computer. Sorry guys, he said that his computer crashed. He'll be right back. Just give him a few minutes.
Okay.
By the way, guys, if in the meantime you have any questions to pose for the last section, feel free to just do it while we wait for Yongtian to come back.
Hi, it's me again. I have another question. Can you hear me?
Oh, sorry. Yeah, I had to unmute.
Yeah, it's okay. Right. So I just quickly searched out on Google. So like what return zero means in C++.
Mhm.
So Google says that return zero means the program is executed successfully, while return one is unsuccessful. So what if we would put return one?
That is technically true, but in this case, the reason why the real reason why we put the return zero there is because we used it as a placeholder for our function to even work. So basically, with functions, right? Like maybe you already knew this, but with functions, you need to return some value in order for it to even be carried out in the first place. So if we hadn't put a return anything there, it would have likely been either an error or it's just bad programming practice in general.
Right. So what if we would put return one instead? Would it wouldn't run?
I think by putting return one, in my experience, there shouldn't be much of a difference. Maybe there is, but I've always been putting return zeros personally lah. So
It's just 1 or 0, right? Like binary 1 or 0.
yep, for sure.
All right. Okay. Thank you.
Yep.
Could you put like the return type as void instead of like integer?
Oh yeah, for sure. For sure. Sorry guys, give me a second. Okay, so Yongqian says that he's gonna take a while to restart, so I'm just gonna carry out his section for him first lah. Oh, sorry, I didn't see the questions in the chat. Nicholas asked, why is there the need for parentheses? Okay, so for parentheses, right? It's just part of the syntax for, if you're asking specifically for functions, it's just part of the syntax. In order for a function to be defined, you need the open and close parentheses. And what's inside the parentheses is a bit less important because those are depending on what your function does, those might be some parameters or values that you might want to include in them. As for Azri's question to check, why is there so many variations for just a simple hello world program? If you're asking in general, like why everyone codes a hello world program differently is because of, well, different programming styles. But if you're asking why it looked different in the slides, I believe I used the same one. So yeah, I'm just gonna assume you're asking about variations across programmers. Okay, guys, if I'm gonna start sharing my screen in a second. So if it works, please let me know. Okay, so I guess I'm just gonna do Yongqian's part for him first. So yeah, variables. Let's just say that you have a bunch of math worksheets that you need to put somewhere, but you don't want to do it now, right? So you put them in the locker. So you store the worksheets in the locker. Afterwards, you decide that you're in the mood to do some work. So you go to the locker and retrieve the worksheets. The concept is basically what variables are. Variables are storage locations in a computer's memory used to house data. In the previous examples, the worksheets can be seen as the data, while the locker can be seen as the variable. With variables, you can store and retrieve data just like worksheets and the locker just now, but you can also manipulate them, which I'll get into later. So here we have some commonly used variable types. You can see that the data types fit into which category. So for example, for integer, you'll have things like 1 or -24, 958. These are all whole numbers or integers. We also have doubles, which are like, they are basically decimal numbers. So 2.5, 3.1415, this is pi basically. Negative 66.0, these are all decimals or doubles. We also have characters, which are like a singular capitalized A, or maybe you have a question mark or lowercase f. These are all singular characters. And also we have strings, which are basically chunks of letters, like just words. We got hello, world, cheese, what. Basically, strings are either whole coherent sentences, or they can just simply be words, simple words. Note that only certain data can only fit into certain variables. And you cannot fit a string, for example, like hello world, into a double variable, because that will result in error. So here is some coding practice. I'm just gonna let you guys try by declaring a variable and initialize a variable and assign a value. Let's give you guys maybe 5 minutes until 2:25. All right, guys, I hope you had fun with that. Let's move on first with with the lesson. So let's talk a bit about variable manipulation. There's different ways of manipulating your variables, and in this case, we are taking a look at a few with integers and strings. So there are arithmetic operators that can manipulate data. We've got your standard things like addition, subtraction, multiplication, division. The more special one that you haven't seen before probably is this percentage symbol called modulo. Basically, what modulo does is that when you divide two numbers, it gives you the remainder of that division. So for example, if you took 9 modulo 4, if you divided 9 by 4, you know you'll get a remainder 1. So thus, the answer to that would be 1. So here are some examples on the left of some integer manipulation. So we define integer x as 0. And x is, well, 0, not 0, sorry. If x is 4 plus 2, then we have x equals to 6. If we have x is 4 modulo 2, then x would be 0 because 4 divided by 2 is 2, and there is no remainder. We can take a look at some of these other examples that should be quite self-explanatory, such as x is 4 minus 2 or 4 times 2. If we have y defined as y is 5, then 5 equals to then, oh, sorry. My bad. Okay. These aren't linked together. If they were linked together, then you can interpret this section on the middle left as defining y as the number 5. And then number 5 is, and then 5 would be y equals to 3, and thus this new y will be equals to 8, and then you output the number 8. That's one way of interpreting it, but I'm guessing Yongqian didn't want to link these statements together. So here's for strings. So for strings, you can define z as the string high. You can also add strings together, surprisingly enough. And if you were to add strings together, you literally just join them up together, just mash them together. So for example, over here, when you wanted to output z plus z, you get high because z is high. So yeah, hope that was clear enough for you. And moving on, we have this thing called output chaining. This is another practice for you guys. I think maybe 5 minutes was a bit long, so maybe let's do 3 minutes. Let's give us until 2:30 and let everyone try a bit of output chaining. All right, so now that you guys are a bit more familiarized with the concepts of strings, integers, and output training, here's a neat little challenge for you. Converting Fahrenheit to Celsius. So the challenge is that by using variables, output training, and manipulation, you should be able to write a program to convert an inputted temperature, which is in Fahrenheit, into its Celsius form. Here's a hint for you guys. The order of operations still works. So brackets will always come first. Multiplication and divide, like the multiplication and dividing principles still apply. Yeah, try your best. We gave you the formula for the conversion here. If you're able to do it, let's say in 5 minutes. So we'll give now from 2:30 to 2:35. Just try this challenge out.
Hello, can you hear me?
Hello.
Hi, it's me again. So I want to ask about the data types, right? So
Yeah.
for C++, for decimals, it will be double, correct?
Correct.
Yes. So in Python, it's called float though. So are those two terms interchangeable?
Yeah. Actually, that's a very good question. Doubles are basically kind of C++'s equivalent of floats.
Ah, okay. So
Yeah.
so you can't call it floats in C++.
Yeah. Unfortunately, it's just like the syntax of C++ lah.
All right. Thank you. Thank you for clarifying.
Sure. Speaking of which, it's time to move on. So if you guys had tried the challenge, this could be a possible solution to it. So let me walk you through it a bit. So over here, this line 7 where they ask you to enter your temperature in Fahrenheit. This is the output. So basically the terminal will output, please enter your temperature in Fahrenheit. And then you would want to input you would want to do a C and I statement, the cin, and ask the user to input the temperature in Fahrenheit. Then next, you would create this in line 11, you would create this line where you did the Celsius to Fahrenheit conversion. So Celsius is equals to Fahrenheit minus 32 over 9 times 5. This is the formula for that. And then you will output the temperature is, and then using the output chaining Celsius, which is your converted value of your temperature, degrees Celsius. And then in the terminal, it should look like this. Enter your temperature in Fahrenheit, and you say you type in 212. Then here from line 12, from the output chaining and the variable manipulation, you would get the temperature is 100 degrees Celsius. So I hope you guys had fun with that. Let's move on to conditionals. So with conditionals, over here, it's best explained that we have a list of groceries and note how you want to always buy bread and chicken, but only buy milk and apples if their respective conditions are met. So they fall below a certain quantity. And also note how you will always buy, what's this, instant noodles, unless the condition is met. So there are already 5 packets at home. So this can be translated into C++ terms by what is known as conditionals. Yeah, so with conditionals, in this case, with milk and apples and instant noodles, these are the conditions to be declared, whether or not you want to carry out or not carry out a certain action. And with that, let's give a quick overview of the conditionals that we'll be using in C++. So there's if, else, and else if. So the difference between these three is that if is always used first. If this condition is met, then you carry out this. And then else is the other by default conditional that should always be used. Else is if the if conditional or the else if conditional is not met, then the else, whatever that is under else, will be carried out. It sounds very confusing, and you might be wondering why not just have an if conditional? Why even bother with an else if conditional? And you know what? I agree with you. It's kind of stupid, but that's how programming is. There's a lot of syntactical nuances and stuff like that that we just have no choice but to follow. So by default, the order of the conditionals in this case should be something like if, else if, and then else. Let's just say that you only have 2 conditions, then it might be something like if and else, and there's no else if. We also have relational operators, logical operators, and switch statements that unfortunately I am unable to go into deep detail since Yongtian was supposed to cover them. But I think the next few, oh yeah, okay, good. The next few slides should cover this in detail. So for these, yeah, as I mentioned earlier, if the if statement is the starter for this kind of conditional, the statement will check if the condition inside its parentheses is true. So if it is, then it runs the code beneath, like over here. In this scenario, I believe you define the variable of weight. So if this variable weight is equals to 60, I should also mention, by the way, that in that double equality signs is not the same as equality signs, single equality signs. Single equality signs in C++ at least are always used for variable definition. Double equality signs are used when you want to literally equate if you literally want to equate a variable or integer to something else. So sorry, not just variables in general. It doesn't have to be integers, but integers are a good example. For example, if we had defined our weight as 65, in this case, the double equality sign is saying if the weight itself, the variable, which is 65, is literally equals to 65. So yeah, it's confusing, but you have to make that distinction. And then you will out, and then if this condition is satisfied, you will make the output of yes. So the weight is 65. And in the terminal over here, you can see that what is outputted to us is yes. Now here we have the else statement. So the else statement and the code below it is what will run if no other conditions are true, and thus no other code is run. So for example, if over here, if we change originally the variable declaration to 0, so we assign 0 to the variable of weight instead of 65, we now know that weight is 0, is not 65. So in this case, because the compiler will run through the function, it sees that, hey, the weight is not 65. So it skips the if statement, the if conditional, I mean, goes to the else conditional and outputs no, because it recognizes that, hey, this isn't 65, which is what the if conditional will output if it had been, like over here in this previous example. So anyway, moving on, finally for the trio, we have this else if conditional. Else if is for additional conditions, as I explained earlier. It's quite likely that you will need to implement more than one condition. So this statement basically acts as if as an if statement, but if the condition in it is true, the code below it would run. So it's the same as if and else statements in the sense of functionality. Usually this is kind of relational with all three statements. It will be called an if else conditional. But okay, so let's see in this example, our weight now is 45. So the compiler will run through the program, sees that, oh, the weight isn't 65. So let's skip over the if conditional. Now we come to the else if conditional, and yes, indeed, the weight is 45. So we output maybe. So this is once the compiler has run through the entire program, we will get the output in the terminal to be maybe, because the condition for the else if conditional is satisfied. Next, let's talk a bit about relational operators.
Excuse me.
Yep.
What if we want to put a range for the if statement?
Sorry, can you come again?
A range of what if we want to put a range of numbers for the if statement?
Oh yeah, okay. So if you wanted to, so basically what she's asking here is that what if in this example, let's just say that if we wanted if we want to give a range of weight. So let's say over here in line 7, we inputted the weight to be 20. And then we say that for line 8, if the if conditional, we wanted a range, so it will be something like if the weight was between 10 and 30. So because now there is a range and 20 satisfies that range, we'll still get the output for if, which will be yes. So does that answer your question? Or are you asking a bit more about the syntax?
Yeah, like how do we like write it down?
Okay, I can't share two screens at the same time, but if you want to code this out, it will be something like replacing the brackets in, the code within this parentheses in line 8 from weight equals to 65 to weight is between, and then you put the inequality symbols beside them, and you put maybe like 10 and 20. Kaiti is asking how to make multiple sentences be displayed on different lines instead of the same line. How to make multiple sentences be displayed on different lines. Oh, okay. The admin answered that question. Yeah, you can print your output with the \n. That would just mean that you'll make a new line. Okay, yeah. So anyway, moving on, we're talking about relational operators. So to complement if-else statements, we have this thing called relational operators. So here I have a bunch of if statements that compare the value of the variable a to the number of 66. So these operators are pretty much identical to the inequalities that you will find in math. I want to bring your attention to the equal operator. Earlier, you'll remember using the one equal sign to initialize a variable. But for relational operators, you'll have to use two equal signs. Otherwise, the computer will think that you're trying to initialize a variable in an if statement, which will return an error. So on the right, in the blue, the turquoise highlighted square, I believe Yongqian included some examples for relational operators. Again, earlier I was trying to explain the difference between the equals to and the variable assigning equals, like what's the difference between them. Yeah, this is pretty much try to think in terms of, for the single equals, try to think in terms of variable assignment, and for the double equals, try to think in terms of relational operators. Yeah. So you can read through the examples. We will be moving on to logical operators now, which basically lets you shove two conditions into a single statement, which can be pretty handy. So like the first two should be pretty self-explanatory. Let me explain the not operator. So in here, you can see that the help variable has the value of false. The statement is now asking if the reverse of the help variable is the value true. This is correct. So therefore, the no is printed. I hope that makes sense. Just gonna give you guys 1 minute to digest. Again, on the right, there will be some logical operators to compare data, such as the and the or, and the not, which are represented by whatever that's in the parentheses. You can also type the words instead of the symbols, but I guess it kind of depends on your personal programming style. Moving on to switch statements. So finally, we have these switch statements. They're basically kind of like a convenient if-else conditional. Default is basically your else statement. In that case, this is what the computer basically runs if there's no other case that fits. Note though that switch can only be used with integer values. Also, there is a break line in every case. This is to ensure that only one case is run instead of the entire thing. So again, these are convenient conditionals for integer values. They are pretty much identical to if-else. And over here in line 23, I believe there's a break. Like what break, line 23, line 19, 15, and 11, what the break does is that it will stop the code from running once that condition is satisfied. So in the interest of time, because we basically have 10 minutes left, and I'm just going to skip over this challenge, but you can always take a picture and try this in your own time if you're interested. All right, so I assume that everyone is done. Okay, let's move on. This is the possible solution to that. Again, feel free to take a picture of this if you are going to be trying this in your own spare time. So finally, loops with a very funny meme as generously donated to you guys by Yongqian. So what are loops? Well, sadly, we are not talking about fruit loops like what was shown in the meme. So let's just say that we have a ceiling fan. Okay, sure. We have a ceiling fan. It cools people off, so there's not much to say here. Well, it spins when you turn it on. It stops when you turn it off. So what we want the fan to be able to do is that the fan will keep spinning until we tell it to, right? So after we press the switch, the fan should spin and stay that way until we turn the switch off. So this is the basic idea for how loops work. Loops involve repeatedly executing some code until a certain condition is met. This condition could be, for example, an integer exceeding a certain value or a string reaching a certain length. So it's really up to you, the programmer, to decide. So we have two main types of loops. We have while loops and we have for loops. And while loops basically let the code run until the specified condition in the brackets is false, this can happen for pretty much forever. So as long as the condition is not met. Here you can see that my first inputted password was 7777, which does not equal to 1234. So the condition is true and the while loop runs. This happens again when I input 432. However, when I input 1234, the condition is false since the password is equals to 1234. So the loop stops. So you're breaking out of the loop. That's like the technical way of saying it. And the code inside the loop is skipped. Next, let's talk about for loops. So for loops are similar to while loops. It will keep running until the condition inside the loop is false. Unlike while loops, for loops usually run for a specific number of times. So here I declare the variable I to have the value 0. So I++ means that I increases by 1 for every, sorry, yeah, the I increases by 1 for every iteration. So I lesser than 10 would be the condition for which the loop will execute. So during the first run, I equals to 0. So I lesser than 10 is satisfied. So I is printed and I will increase by 1 before the next iteration. So during the second run through the loop, I is equals to 1. So I is still less than 10 and I is still printed. So this keeps happening until I is equals to 9, where I is printed and then increased by 1. But by the next run, so the final iteration, I is equals to 10. So I less than 10, as you may have noticed, is false. If this condition is not fulfilled, this is false, the loop will stop. You will break out of the loop. So I hope that was comprehensive for you guys to understand. Again, we'll be skipping over the challenge, but feel free to take a picture of the challenge and its solution. Here's the solution for you guys. All right, so that should be the end of our workshop. I'm so sorry for the technical issues. So apparently what happened to Yongqian was that his house literally had like literally had a blackout. So he was unable to, he had no Wi-Fi, he had no internet connection, and his PC basically died on him. So I had to take over. Hopefully, I did a good enough job explaining his parts because I do not have a script and I was kind of like going off. So yeah. Again, if you have any questions for this part, you can either ask me, and if I can't answer them, I will for sure relay them to Yongtian, who is now on WhatsApp, and I can just ask him, and I can just relay those questions to him. I will give about maybe 5 minutes to like 2:50. Oh, it's already 2:56. Okay, so maybe I'll give around 3 minutes for you guys to ask some questions, and then I'll hand it over to the other admins who will do some administrative stuff.